Morning all, wishing you all the World Water Day celebration today. So we know the importance of this day, the value and the preciousness of water day by day. So as per the United Nations, this World Water Day is being celebrated every year on 22nd of March. This is happening right from the year of 1993 to focus on the importance of fresh water. So World Water Day is being celebrated to raise the awareness to the people for access to safe water. It is all tackling on the crisis of global water. It focuses on the Sustainable Development Goal 6, that is water and sanitation for all by 2030. So keeping this day in mind, our Sathyabama Institute of Science and Technology, our Center for Ocean Research, jointly with our Center for Remote Sensing and Geoinformatics, and also from the Department of Civil Engineering, in association with our Earth Science Technology Cell, Ministry of Earth Sciences, and also with IUCN Commission on Ecosystem Management, we are celebrating this World Water Day 2022 today. So our Center for Ocean Research has taken the efforts to arrange an online faculty development program with the theme Sustainability, Conservation and Protection of Water Resources, which is being framed to showcase the importance of water resources, and hence we all have gathered here for the same, for this entire day. I first of all want to thank our Vice Chancellor, Dr. T. Sasiprabha, who had given her consent to be a part in this World Water Day program. Also, I thank Dr. Shalini Dhyani, who is Regional Vice Chair, South Asia from IUCN Commission on Ecosystem Management, for her presence today and being the representative of this IUCN CEM technical partnership. Further, to add a note onto this need for the day, the focus is mainly on the groundwater, and which is an invisible resource with an impact visible everywhere. It is very, very critically important to the health functioning of ecosystems such as wetland and rivers. We must protect them from overexploitation. It can lead to the depletion of resources, extra cost of processing it, and sometimes even prevents its use also. So exploring the use of groundwater and for surviving and for adapting to climate change, all is a need for the present growing population. So keeping all these things in mind, as a end note, I hope this online faculty development program will be a wonderful, wonderful platform for all the participants to raise the awareness on water. So once again, wishing all on this World Water Day. Thank you.
Thank you, ma'am. Thank you for your words, ma'am. Now, I would like to invite Honorable Vice Chancellor, Dr. T. Sasiprabha, to deliver presidential address.
Very good morning to the organizers, so Director Research, and our technical partner, Dr. Shalini Dhyani, Regional Chair, South Asia, IUCN Commission on Ecosystem Management, and all the scientific team from Center for Ocean Research and Center for Remote Sensing, and all the other scientists and faculties of our centers and the departments and the participants. So you all know that the importance of water. So now, already for the past few decades, we started realizing the importance of water and the scarcity of water, mainly in the urban areas. And there are a lot of scientists working on regenerating the water. At the same time, the government is also taking effort to conserve the water and preserve the water. And also, they are also finding out new and novel technologies to take water from either from sea or from other sources, even from air. So the technology have come up. So as a scientific community who are assembled here, so our ultimate goal should contribute something for the society. But the contribution towards water research is really in need, and directly to reach a layman, the common man, immediately. So even our DST, when I was talking with a few scientists in DST, they were telling, so we are funding so much of fund for doing a lot of research activities, but at the end, it is actually stopping only with the paper and the report. Finally, it is not reaching the public, because we are spending from the public fund, and it has to reach the public finally. So that is not coming from the institutions who are undertaking the projects at large from various funding, other funding agencies also. So all the scientific team who are here and who are executing the ongoing projects, whatever may be your area. So try to come out with some novel solutions, innovative solutions, so that the society should use your solutions finally, at least or to the industries. So let us be the small contributors for the growth of the society. And towards this water concerns is very, very important. And that's why this World Water Day was celebrated, is being celebrated throughout the year. And just to spread the awareness, as the Director was telling, spread awareness about the importance of water and what all the scientific contribution or technical contribution we can do in getting more water, so that our future generation will get surplus water. And the conservation of water is also very, very important. So let us take this vote as a scientist. Let us populate this message to all our stakeholders, including the rural people or the nearby villages people. So we got to keep communicating them the importance of water, how to conserve the water. And these are all very, very important. So I hope our scientific community who are here can able to support this initiative for the United Nations. And I am also thankful for Dr. Inbakandan and the other scientific team who have taken effort in identifying the good speakers. I was able to see good number of speakers. So they are going to enlighten you, and so that you can also get some ignite towards water research is concerned. So thank you for the opportunity.
Thank you, ma'am. Thank you for your encouraging words, ma'am. Now I invite Dr. Shalini Dhyani, Regional Chair, South Asia, IUCN, CEM, for the special address.
Shalini ma'am, you have to unmute you.
Good morning, everyone. I hope I am visible and audible to everyone.
Yes,
a very good morning. Yeah, very good morning and a very happy World Water Day 2022. I am so thankful to Dr. Inbakandan and also to the Director Research, Dr. B. Sheela, Rani, and all the important experts on the panel, because I think this is the second or third time on the panel of Sathyabama Institute of Science and Technology. And I must say, it is a proud privilege of IUCN Commission on Ecosystem Management South Asia regions to be part of this event. And I am also thankful that you all are doing a great job of creating and generating a lot of awareness to young generation, to teachers, faculty, and scientists, and so many other important stakeholders in this program. While little bit I would like to say about IUCN Commission on Ecosystem Management. Dr. Inbakandan is also one of the members, and recently he has also been appointed as co-chair for aquaculture. So I think this is a great moment for India, where we have a good amount of leaders right now from India for South Asia. And freshwater ecosystems, marine ecosystem, oceans, and then so many other brackish water ecosystems are some of the important ecosystems that we all are working on. But when I talk about present World Water Day, I think the most important concern right now for the country is groundwater. And that's why there is a huge emphasis on understanding and making the invisible visible. Now, we all know that across India, most of this groundwater, about 90% of groundwater goes for irrigation purposes. And about 24%, about 24 billion cubic meters of water goes for 85% of water requirements of the country. So you can assume almost 80% of population, 85% of population of this country is dependent on groundwater for one reason or another reason. We keep seeing these shortage issues. Urban areas are one important areas to work on, but again, the situation is no different across the country. Groundwater is depleting very fast, and that's why there is a huge concern that we raise awareness. Because I personally, as a scientist in one of the important Council for Scientific and Industrial Research laboratories of the country, we're working on critical zone research. And we are trying to see what are the reasons that groundwater is depleting so fast. So what are the important reasons? One of the important ones is don't follow precision irrigation. If you see, most of the farmers are focusing on flood irrigation, and the most important reason is because they're not aware. you give free electricity, subsidized electricity that goes in enhancing water extraction from groundwater, and that makes the entire region critical. So in the area where I sit is one of the water short areas in Vidarbha region. And again, you also hear a lot of farmer suicides because of crop failure because of insufficient groundwater to support their agriculture. So it's highly important that through this panel also that we raise this voice that why it is so important that we talk about groundwater now before it's too late. There are already alarming reports that India's many urban centers, Delhi, Bangalore, are going to be having no groundwater, or they will be in the critical stage, or they are already in the critical stage. So this awareness is very important. Now, when I talk about awareness, what can be the good ways of generating this awareness? Now, in this context, the context of nature-based solution comes into the light. Once we understand that our ecosystem is stressed because of water issues, and these groundwater issues are not only going to affect people, they are going to affect the ecosystem, they're going to affect the other kind of ecosystem services. They may be regulating, they might be affecting our biogeochemical cycles, they might also be affecting the soil fertility and so many other components. And once these regulating and supporting services are affected, we are sure that the provisions that we get from nature, the nature's contribution for our well-being is also going to be affected. So to ensure that proper capacity is built on ground, we need to ensure that we support nature-based solution. Now, I don't have so much time to elaborate more on nature-based solution, but briefly, this is something that's not nature conservation, that's basically addressing societal challenges by identifying relevant nature-based solutions. For example, if you're talking about groundwater depletion, we need to understand that what may be the important plants, what may be the important trees that can have good water storage that can help enhancing groundwater or aquifer recharge in the zones. I'm sure we all will be convinced that native trees can be a better option. I was recently in one of the panels of High Court of Madras panel where there was a concern on Prosopis juliflora being, that's the local babool that you call in Hindi. So that spread across many parts of Tamil Nadu. So the reason was that there is a concern that most of these invasive species are actually sucking up our groundwater. Now, we don't have enough of database to say that, we don't have evidence to say that, but good way can be to have a phase-wise removal of these trees and replicating it and alternating it with trees that are more suitable to our agroclimatic zones and that can help groundwater recharge. Now, this can help groundwater recharge, and at the same time, they can also get a lot of co-benefits. Now, this is the beauty of nature-based solutions, ecosystem-based approaches. They not only address your societal challenges, they also give you a lot of co-benefits. So it can be sustainable livelihoods, it can be good pollinator biodiversity, it can be good carbon stocks, it can be also disaster risk reduction. So these are the things that are now very much implemented. They're very much mainstreamed in international policy dialogues. We talk about Glasgow Climate Pact, where this has been included as nature-based climate solution. And now even Indian government is also trying to include a lot of them in a lot of relevant policies. But again, a lot of capacity on the ground, and especially all the faculties from different parts of the country who have joined this program. You are one of the flag bearers and you are one of the people and stakeholders who can actually take this message back to the students, the next generation of scientists, to actually explore these innovations. Don't replicate something that is happening in central India or Kerala or any other part of the country, because these ecosystems are very, very specialized ecosystems. You have to identify a very customized solution to the regional, local, societal issue. It can be climate change, it can be groundwater issue, it can be a marine related issue, or it can be sustainable aquaculture or sustainable livelihood. So these are n number of ways, and you all are experts in your own fields. I also urge you all to not only sit on your silos, go and talk to your transdisciplinary and multidisciplinary partners, colleagues, and maybe you will be able to find more innovations and more appropriate solutions. I think with this, I once again congratulate you all, and I wish you all a very best of luck for the next 3 days. I saw the list of speakers. I know they are best of the best that you all have chosen. So I look forward to hear a lot of them. And I also request that if it is possible, make sure that your lectures are on YouTube so that we can share it to our partners and our network. And we have a large network in South Asia and globally, and really want to promote it. Thank you so much for this invitation once again, and a very happy World Water Day to everyone. Thank you.
Thank you, Shalini ma'am. Ma'am, actually we are arranging for the YouTube recording also. We will do that. Thank you.
Thank you, ma'am. Now it's time for vote of thanks. I invite Dr. Bhagyalakshmi, Head and Professor, Department of Civil Engineering, Sathyabama Institute of Science and Technology, for vote of thanks.
Good morning to all. It's my great pleasure to propose vote of thanks on for this inauguration of this 5 days online FDP program on sustainability, conservation and protection of water resources that we are conducting to celebrate to commemorate the wonderful day, World Water Day, on March 22nd, 2022. First of all, I want to thank the management for providing all the facilities to conduct this online FDP program. I thank our Vice Chancellor Madam, Dr. T. Sasiprabha, for motivating us, guiding us to conduct these sort of days of importance program. And I thank Director Research Ma'am, Dr. B. Sheela Rani, for coordinating this, and all the process, step-by-step process, and after the motivations Madam is giving for the successful coordination of this program, 5 days FDP program. I thank all the organizing members, co-conveners, all the faculty members, the scientists, the students for attending this program. I thank Dr. Shalini Dhyani ma'am, Regional Director, South Asia, IUCN Commission on Ecosystem Management, for giving this eye-opening talk, inaugural talk today. Thank you, ma'am. I thank all the participants. I thank last but not least scientist Brigida ma'am for coordination and for giving that Zoom link for the successful coordination for this online FDP program. Thank you, sir. Thank you, Inbakandan sir. Thank you, all the moderator coordinators. I thank all the participants. I hope these 5 days will be very fruitful. This sort of the program really is a societal event to import the awareness on this on water resources. Water resources are fragile and vulnerable resources. We know very well, but this is the need of the hour to implement the things, scientific things, to the society level. Thank you, sir. Thank you all.
Thank you, ma'am. Now we have come to the end of the inaugural session. Now it's time for our interesting technical sessions. Today we have with us Dr. Paromita Chakraborty, Leader, Environmental Science and Technology Laboratory, Department of Chemical Engineering, SRM Institute of Science and Technology. I would like to introduce the speaker before the technical session. Dr. Paromita Chakraborty is an associate professor at Department of Chemical Engineering in SRM Institute of Science and Technology, Kattankulathur, India. Dr. Chakraborty leads the Environmental Science and Technology Research Group, and her group is intensively working on fate, transport, and cost-effective remediation techniques for legacy and emerging organic contaminants. Dr. Chakraborty is the principal investigator for projects funded by national funding agencies like DST, MOEF, CC, ICMR, and international funding agencies like Indo-US Science and Technology Forum, Research Council of Norway, Norwegian Embassy, and SIST Development Corporation. Her recent investigations on chemical markers for COVID-19 surveillance in community wastewater gathered attention among the stakeholders. She has published over 100 scientific articles in peer-reviewed international journals, including Water Research, Environmental Science and Technology, etc. Book chapters mostly in Springer and elsewhere publishing houses. She is an associate editor for the Arabian Journal of Geosciences and is the editorial board member in the Science of the Total Environment. She is also the corresponding editor for Springer Germany book on legacy and emerging contaminants in water and wastewater monitoring, risk assessment, and remediation techniques. Dr. Chakraborty is a recognized mentor for Association of Commonwealth Universities, ACU, Blue Charter Fellowship. She was awarded with Hiyoshi Environment Award 2020, prestigious Water Art Advanced Research and Innovation, WARI Fellowship 2016, Early Career Chemist 2015, and numerous travel grants by ACS and other research organizations. Dr. Chakraborty holds a patent for production of polymer-based pencils from plastic waste. Dr. Chakraborty supervised 5 PhD scholars. She has 5 ongoing PhD scholars. She has also supervised over 15 BTech and 10 MTech theses. Dr. Chakraborty also hosts fellows and interns from national, IIT, ISER, and international institutes in her laboratory. It's a privilege to have you with us today, ma'am.
Thank you very much for giving me this opportunity and sharing this platform today. I just try to share my screen. Is it visible and am I audible?
Yes, ma'am, it is visible and you are audible.
Yeah, I just, before I start, just please excuse us. There is some power cuts going on since this morning, and quite a couple of times during the inaugural session, I was disconnected. I hope it goes smooth. So good morning, and it's really a wonderful day, especially for all of us who work on water, who try to preserve water. So today my talk is on pollution sources and the risk assessment of plastic additives in the River Ganga. When we talk about the fresh water in our country, Ganga is like one of the most biggest river, transboundary river, and it caters to more than 40% of India's population and is a snow-fed river, so a major source of fresh water for us. So I'll take you to the story of this plastic additives. So, a lot of plastics are ending up in the riverine belt. So I would take it to River Ganga. Also, I would include Sundarban wetland, also some of the sites we have considered, because it houses a lot of huge biodiversity, and the ecosystem is very unique there, and it's world's largest mangrove, housing the world's largest wetland. So to start with, like, these are the pictures we took when we were working in the Ganges. And as you were introducing me to this lecture, a part of his work was part of the WARI Fellowship as well. But extensively, we have other funds to work on Ganges. We are also working on other rivers in southern India, but I thought like this major freshwater source would be interesting as it is a transboundary river. So what we started, what made us start to work on Ganges? Of course, I was born and brought up along the bank of this river, bit fortunate, I would say, because the river is very interesting. You know, it can take up all kinds of waste, and still it can be the holy water for us. It can be holy for us. But the important part is water quality. Even I think during my grad studies, we were seeing that there's huge lot of pollution associated in the Ganges. And again, it is important to protect this important freshwater resource. We have very limited freshwater resource. And again, when it comes to groundwater, the water table in southern India is much lower compared in the northern India. So the surface water and groundwater can have a similar level of contamination. So those things also we need to keep in mind. So the problem statement in Ganges was, one is this entire belt, Indo-Gangetic basin, supports a huge agricultural space. So the pesticides that are being used do end up in the river with the surface runoff, or sometimes even with atmospheric deposition. Then the industries, definitely there are several industries of different types, and we know the middle stretch of the river has a lot of industries which are polluting. Lower stretch, maybe again the flow of the river, the volume of the river, all this makes a lot of difference. And then comes, we do dump waste, we have the practice of open burning, dumping the waste. And most importantly, there are several cremation grounds, which along the bank of the river, because it's taken as a part of a holy practice. So everything goes fine if it is in a control, but this is not in control. So we see a lot of issues along the river that are being, the discharges that are coming to the river. Now coming to, because I was talking mostly on plastic additives, though we work on pesticides, we work on a lot of other endocrine disrupting molecules in the river. But today I would be limiting only to the plastics. There was this interesting news in 2017, like the major rivers that are carrying plastic waste, Indus, Brahmaputra, and Ganga are among the top of those. And you can see here how we dump waste plastic bottles or waste plastics along the river, and also sometimes the religious practices that we have. Many a times, I believe, if we are praying a holy river, we need to protect it. And one very, very important fact is like this burning of the waste along the river belt. This is again not Ganges, of course. This is in Vapi, a river, a small creek in Vapi, the different other rivers. And you see this area, this just within an hour, this place was subjected to open burning. And you can see how rivers in general, it is happening along rivers in Chennai like Adir and Kuam. Even along Kaveri we are seeing like, so the river, even in Gujarat, Vapi, Daman, Ganga, Vapi, and then Tapi in Surat. We are catering to a lot of rivers across the country, and these practices are pretty much common. And if the river is a source of fresh water, there are a lot of freshwater species, including fishes, and that can be again loading a lot of contaminants that are there in the plastic. So with this idea in my group, what we are trying to work out, a lot of legacy and emerging organic pollutants. What we try to understand is when they are released in a source in a hotspot area, how they are having multimedia movement and where the molecules are getting transported to. And we are also looking into some sort of cost-effective remediation techniques. Now, the contaminants we are targeting are mostly endocrine disruptors. Means these contaminants can be very deadly. They disrupt they block the pathway for the hormones. So the response for the hormones changes, and in addition to that, like they can lead to carcinogenic impacts, and there can be several problems associated with this kind of endocrine disrupting chemicals. So these are very, very important to understand. Now, how do we see this? With the talk, I will tell you, like, how does this chemicals comes in the form from the plastic? Like we talk about the problems associated with the plastic. So I'll brief you on that, and the story would talk about this. And the case study is on Ganga. Today, the focus is on Ganga. And then I would also like to show you some of the sustainable approaches we are taking in this regard. So first, starting with what is the plastic, the source of plastic additives, the backgrounds of this, and why it could be a problem. Let's see. Plastics are there almost everywhere, starting from this baby bottles and all the medical stuffs, and also anything that we have, the packaging material, even the laptop we are using has a casing of plastic. Even the printed circuit boards have plastic that are there within any of these electronic gadgets. So plastics are there pretty much everywhere, starting from the food to the baby stuffs, the playing stuffs, to anything that we are using. So sometimes we see that it also enters to our diet. So what happens to this? What are we actually looking at? There are a lot of chemicals that are added to the plastic at different stages of its manufacture. Depends on the products again, like what are the kind of products we are producing. Based on that, the plastic additives are added. Now, Stockholm Convention has stopped a lot of persistent organic pollutants, and they have come up with a lot of stricter rules. In that, like there are certain compounds, like it could be some of the short fluorinated chain paraffins, or some of the brominated flame retardants, which should be eliminated, or polychlorinated biphenyls, which should be eliminated, and they are enlisted in Annexure A of the convention. And there are some chemicals which are under restriction, which comes under Annexure B, like PFOS, which are actually now a lot of hue and cry is coming out with PFOS. And then there are some unintentional ones which produces, like open burning releases a lot of dioxins, furans. Even we are seeing dioxin like PCBs. So those markers that are being produced, those are unintentional releases. Those are categorized as Annex C. And there are a few compounds which are still under review. We need to understand whether we should restrict them from usage. So these are the chemicals which are there in the plastic. Now, I was telling you, like, the laptop I'm using or the cell phone you are using, all the electronic gadgets we are using, that is another arena. And we had one project from PST and ministry also, like, where we were looking into this of the chemicals which are added to the electronic gadgets, these plastics. The plastic gadgets can use a lot of plastic additives. Also, flame retardants can be added to gadgets, because most of these electronic gadgets, 80% are made up of metals and plastics. So then metals has precious metals in it, which could be lucrative for business part. So people won't misuse it. When we add value to a product, it is not misused. But then plastic, some segment of the plastics, not just the casing and etc. Some segments of the plastic, like printed circuit board plastic, when you remove the metals, we tend to throw it away. So, or burn it. So then it raises a problem, and then many a times, many of these waste sludges are ending up to the riverine belt, which is a big question for us, especially in the developing world, because developed world like United States or even European Union, they are not involved in recycling of electronic waste. And in developing nations in South Asia now will get more attention, because China has stopped taking the electronic waste since 2018 January. Because they found a lot of issues. By over 2.5 decades, they were taking the load. 90% of electronic waste was going to China for recycling. So now then the load is more into the South Asian countries. And then that is a big challenge, because we are not understanding where we actually stand. Many of these electronic gadgets, which are made up of different kinds of plastic. Of course, the type of plastics are also differentiated. Some plastics can go for recycling, some may not be able to get into recycling, because again, it depends on the economic value of the plastics. But the flame retardants, the chemicals that are added, like polybrominated diphenyl ethers, a lot of brominated flame retardants are added to this kind of gadgets, and even not only the gadgets, like the foams, the chair possibly we are sitting sometimes, or the sofa cum bed, those also have a lot of this flame retardants, so that it doesn't get fired quickly. So those are the materials which could be of importance. And as for electronic gadgets, we have seen that many of the plastic additives where informal e-waste recycling are taking place in Indian cities, we are seeing a lot of plastic additives are being used. And not only that, like when some of this end up in the open dumps, or in open dumps also some of the gadgets where we were seeing like people discard those in the domestic waste stream, then also like this kind of plastic additives might come in. And so this open burning is becoming a challenge. We have seen in many of our stories that open burning, we try to understand, model the atmospheric movement of these contaminants due to open burning, that these are very toxic molecules, and they can go and affect those places which are pristine in sites like where the activities are not there, because many of these molecules are capable of long range atmospheric transport. So we have seen, say for example, certain pristine sites in Ganges or in Brahmaputra, that atmospheric deposition is contaminating many of this, contaminating the surface water of the rivers with many of these chemicals. And so when coming to like the holistic approach, you see this was the paper I was talking about, like where Lebreton et al. They found like they modeled the quantity of plastics coming in different river systems or across the globe. And you see here where Ganges and Brahmaputra ending the delta part. So there also like the huge loading of plastics, of course, in the Arabian Sea. And interestingly, we are catering to both of these areas now in varied projects. What we are seeing here is like what we are seeing here, like this plastics, the polymers that are manufactured in a good quantity, different areas, but the packaging materials are a big segment. Of course, I was talking to electronic gadgets, which are smaller ones. Then packaging industry or even in building materials, all of the waste materials that ends up in the dump sites, and those could contain a good quantum of plastics. And in this, as I was telling, different chemicals are used. Plasticizers and the flame retardants, they comprise of a bigger chunk, like nearly 35 to 40% of this chunk, entire amount of plastic additives added are this plasticizers. You see the black one, the major chunk. And we actually work on this plastic additives or some of the flame retardants. So today I'll be showing you what happens with this plasticizers. But now, not just before we enter the plastic sizes, we also know the plastics are broken down, the macroplastics are broken down into microplastics, and they are also entering the freshwater or the groundwater systems. And they are there in many products, and they're entering into different arenas because the macroplastics in due course of time would become microplastics, and which is again another important issue that we are trying to arrest. Not only that, like, you know, we are seeing that some of the fruits that are being grown in the soil, like microplastic contamination is there because of the plastic mulching process that is taking place. So this long-term, this fragments of plastics, if they are there in the environment, like they end up to the freshwater system and then, or in the marine system. And it can also impact not only the ecosystem, but also indirectly to the human health as well. And with the plastics, like how the plastics, if they are broken down, they can, you know, with the smaller the size, and it can impact the larger organisms. And you see here, it's like many marine or marine regions, you can see that organisms are ending up being dependent on this plastic waste. And even we are seeing the cows are grazing on plastic waste along the bank of the rivers. And in many other sites as well, like where they are openly dumped. So this organism to plastic size ratio and the impact that can have, it's quite immense, quite huge. So I wanted to show you like how different arena of plastic, not just the macroplastic that I was talking about coming into a dump waste when it is burnt, but leaching of the molecules, and also then again the microplastics that can be also severely important. And again, being this is a hydrophobic in nature, and I tell you, most of these contaminants are also hydrophobic. So if it is hydrophobic and some of these contaminants are highly lipophilic, so the impact is even stronger as it reaches the food chain. So this plastic, even this micro level plastic can have a lot of chemicals inside it. So those chemicals either leached out or they are coming out in other processes with high temperature conditions or normal leaching process. They still have those chemicals, and those chemicals are directly being ingested into lower trophic organisms, and ultimately it ends to the higher trophic levels. Why it happens a problem with the plastics? When I'm talking about plastic additives, let's look into the fact that a lot of chemicals are being added. Even sometimes we are drinking tea, coffee in the styrofoam glasses, or we are using a lot of other chemicals, including the plasticizers, flame retardants, additives like bisphenol A. And importantly, some of these plasticizers, they are actually not chemically added. They are there to improve the durability or flexibility of the product, the plastic product, or giving it a shape. And since they are like added, they are mechanically added during the production phase. So when it is very easy for those compounds to leach out from the different molecules. So you see here different polymeric molecules, as you see here, polyethylene, polyvinyl chloride, or polypropylene, different kinds of polymers. And then this plasticizer, which are added onto the layer mechanically, this can leach out when we are exposing them or we are not handling the waste in a proper manner. In short, what I can say. Not only, and I told you, like I have shown you, that the huge quantum of plastic packaging also gives a very, very important arena. So a good quantum of waste that comes out is, again, the plastics are being recycled, and those recycled ones also after usage, end of life cycle, if ends up with open dumps with burning activity, those are also releasing a lot of contaminants that might come out. And we have seen, even in the food products, we are seeing this kind of plastic additives are even entering in the bovine milk or in the food that we are eating. We had a very interesting story, like where we could see that even packaged product like, paneer, etc., which are vegetarian stuff, are actually loaded with a good quanta of some of the plastic sizes of plastic additives, especially the phthalic acid esters. And this phthalic acid esters, I tell you, like the 6 priority ones are listed by US EPA as a very important endocrine disruptors. A couple of them are, especially diethyl hexyl phthalate. And we are seeing those even in drinking water bottles. Now, slowly, steadily, I'm just trying to give you this introductory phase, because how plastics and molecules interact. We are also seeing, like, the plastics made up of recycled polymer to make certain bottles. Some brands, if you see, they are low cost. Say the good brands, they will sell a 1 liter water in 20 rupees. The recycled polymeric bottles will be coming in 10 rupees, same 1 liter bottle. Those bottles, we have done a model experiment in the lab, and we are seeing that they are able to leach out most of this phthalates or phthalic acid esters in the drinking water. So the bottles which are left out in the shops, the idea was like, if, like in Tamil Nadu, the temperature is pretty high in a summer day, and the bottles are there for 2 to 3 days outside hot sun. So those bottles can leach out a lot of this polymeric material. And this happens in the beaches also. These bottles are thrown away in the beaches. They are there. And after usage also, this can leach out in the riverine surface as well. So what we are seeing now, let's get into the case studies for what, what we are exactly seeing. Coming to the story, after giving you the holistic idea about the plastic additives from varied sources, let's get into this storyline. So what we had done with Ganges is, like, we try to understand the fate of these plastic molecules and what are the sources, from where it is coming, what type of risk it would have. And then we will be seeing some of the sustainable approaches we are taking, which possibly can handle things in the long run. So what sort of methodology we took? So this is very interesting. With our entire group, we were along the Ganges. We covered to 1,700 kilometers in Ganges, here, the Sindhu-Gangetic basin. And we had 14 stations in Ganges, 2 stations in the Sundarban wetland. And we had 3 to 5 sampling sites under each station. And the sampling sites were divided into different categories. We had in the entire stretch of Ganges, the first study, like where we had like the upper, middle, and the lower stretches. But prior to this, we have also investigated a case study area, that is the lower stretch of the Ganges, which is the Hooghly River. And we have got into, like, because this is the estuarine point, the mixing point, the river ending up to the Bay of Bengal. So we were trying to see that how the riverine and the marine fluxes are varying and how it is entering. This kind of molecules can enter into the riverine and the marine belt. So with this idea, and you can see here, these are the dots you see. This is the wastewater discharges that are there along the river points. Like, there are a lot of open discharges are there. You see most of our rivers, like, have direct discharge system to the rivers. And sometimes we do also have seen that the marker, so a marker compound is very much needed, that whether we are getting the STPs that are there, whether they are actually functional or not. So we try to use some marker compounds in the study. So whatever samples we are collecting when we are analyzing for plasticizer, plasticizer was analyzed in our lab, and then some segment was taken up in UNL lab in US for some segment of the study, especially the bioassay and the androgenic study that I'll come to a bit in later few slides. So in general, we collect the samples. We have a process to process the samples. For solid samples like sediment, etc., we go for microwave-assisted extraction, and solid phase extraction for water or wastewater samples. Prior to that, the samples are filtered, and then we subject it to a column chromatography, and then we use instruments like GC, GCMS, GC, and also HPLC or even LCMS, MS. Those instrumentations help. Sometimes it don't have it, like have done that in UNL as well. So whatever data we get, what we try to understand with the data is we try to see to measure the the risk in terms of the risk quotient, like in terms of the partition coefficient and predicted no effect concentration, and with the ratio between the measured environment concentration and predicted no effect concentration. That one way of doing the estrogenicity. But interestingly for Ganges, what we did, we exposed the concentrations to mammary epithelial cells, and then we try to see that whether that concentration is causing some amount of impact to the cell lines or not. So we have done a bioassay screening, e-screening also for those samples. And then we do the chemical flux calculations. We try to see whether the molecules are partitioning towards the sediment or they are retaining in the water. What is the fugacity tendency for the molecule to be retained when it is there in the Ganges? So if it is retained more onto the water, then the water ecosystem has to be concerned or not. That's what we are trying to see. And as I was telling you, like we analyze all this phthalic acid esters in GCMS. For bisphenol A, we are using a derivatizing agent, MSTFA, to derivatize and still analyzing GCMS. And we use a lot of quality control process. Like we do have, we do use a lot of blanks, field blanks, method blanks, isotope level standards to understand the recovery during the extraction process. And we also use internal standards while we are running those samples using the calibration method in GC or other instrumental techniques. What did we see? And now first, I would say that, we had an initial case study with the Hooghly River, where we have done a pool of compounds, a huge pool of organic micropollutants. And there we saw that the pollutants loading are actually more in terms of the plastic sizes. And if you see here, the red ones, like are the ones we could track those as a non-functional STP. How we could track is we could use carbamazepine as a tracker. And later we see that for solid matrix, because this was onto the sediment samples, but if it is, we are using water samples, caffeine is a we could find that as a very good marker for human waste entering in the water bodies or anywhere, even in wastewater, it can be a very essential marker. So the plastic size loading was way more, and if we see that the discharge points, close to the discharge points, the loading were very high, especially of diethyl hexyl phthalate. Now, what we did for the entire stretch of Ganges, as I was telling you, like the concentrations we got for 6 priority phthalates and one additive we added. And another one was bisphenol A. And if you see here, like especially in the middle stretch, we found a little bit of one side near Kanpur, like higher concentration, but then bisphenol A was pretty much high in the lower stretch. And where we have also seen, like this could be from the industrial sources, we are tracing it in the lower stretch from the industrial sources. Now, if you see in the Sundarban wetland, like the areas like where there were more of the human activities, we could see slightly elevated levels. Rather, some locations, these locations are nearing to the Bay of Bengal, and we could see like sampling was done from the boat itself, and we could see some amount of a good quantity of this contamination. But if you see that when caffeine we try to use as a marker, as I was telling you, that where human activities are more, we are seeing more markers of caffeine. So where caffeine is more, we are seeing more of this chemicals. And I was telling you that these chemicals, especially these plasticizers, they are endocrine disrupting chemicals, because these chemicals can bind with the estrogen receptors. So to understand that, what we did, we also tested the hormones, the steroids, those water samples. Interestingly, we found androgen only in 4 sites. There was no other steroids in those water samples at all. But still we could see the impact. If you see here, from a lot of phthalates that we studied, the impact was due to the phthalates. So it means many of these are binding to estrogen receptors, and they are mimicking and they are giving the toxic impacts. The possibility is there. And if you see, we had like the highest bio E2EQ, it means with the cell line, the highest impact area, which area wherever we found it was in the middle stretch locations. These were the sites which were having very high even caffeine concentrations, and we could visually see that two big outfalls were there in the river. So the outfalls are one source of wastewater to the river, and when they're bringing in the wastewater, and they are also channelizing lots of plastic additives that are entering to the wastewater stream. Now, not only that, we also saw that impact, the ecotoxicological impact of this molecules are pretty high when it comes to, especially for those organisms that are there in the lower stretch of the river, that has a little bit a higher impact. And the most impact what we could see is for DEHP, like diethyl hexyl phthalate in the sediment. And in the water, what we are seeing is like certain areas in the lower stretch where tourist spots were there, or more than the industrial areas. In the tourist spots, the loading of these plastic additives were actually higher than those industrial areas even. It doesn't mean that industrial areas were not showing this high quanta of phthalates, but then again, we were seeing more onto this tourist spots. And we could see there, a lot of waste plastic bottles. I was telling you that we have done modeled experiments, and the kind of phthalate that is released from this kind of waste plastic, it can have higher loading of these molecules onto the river. So not only we always talk about industries as the major source, but this could be also an important source. And I have to thank Professor Dan, who helped me, who was my mentor during WARI, and very happy to mention about him. And we had a very, very good collaborative initiative, and still we are ongoing. We are doing that. And one of my scholar, Moitreshi Mukhopadhyay, she was also one of the WARI fellow, and she went the next year, and we were still into this collaboration and doing a lot of work together. And otherwise, like, analyzing with LC-MS was difficult for us, standardizing those methods. So that was happening in his lab, but entire plastic additives, entire work was done in our lab in SRM. And but then again, you see, if you now let's get into the lower stretch where we are seeing, and this is part of Moitre's PhD work as well, like where she's looking into the lower stretch, the fluxes, how they are occurring. You see here that we can see a good gradient between the freshwater and the mixing zone. That's a very, very unique area to study also. So we had a lot of stormwater outlets. Stormwater outlets, of course, those outlets were showing up elevated levels of this contaminants, what we were targeting. And interestingly, with phthalates, we were seeing that more higher in the freshwater system, but as the salinity increases, we were seeing more of the bisphenol A. And with that, when we are seeing, if you see again here, the bisphenol A were impacting actually more. This was more onto the water, but when it comes to diethyl hexyl phthalate, it is more onto the sediment because it is a particle bound compound. So when it comes to the fluxes, when we are estimating the fluxes using the sediment and the water concentrations, we are seeing that particle bound compound are more onto the sediment, wherein bisphenol A or many other lower molecular weight phthalates are more onto water. So this is also another important message that but in due course of time, if sediment is more loaded, this can be released again onto the surface water. And we are also seeing that the eco-estrogenic impact of these organisms were much more higher in the storm water. But if the storm water is released into the fresh water, those freshwater samples are also showing high EQ or estrogenic impact. And if we try to understand, even in the pore water, this some of this low molecular weight phthalates, especially for dibutyl phthalate, they were much higher in this pore water. And then you can see, like, you can understand those can impact the organisms even at lower concentrations. So with this, I would brief you like what exactly are we doing at this phase, and how are we able to handle if this problem is aggravating, what in that case we are doing some of these approaches. Now, during the pandemic time, we were in the field. We were working in the field because of the Swiss project. We were working on COVID wastewater surveillance. During this time, since I'm very much interested into like what's happening to the plastics. See, the huge quantity of plastic that has increased during the pandemic time because of the PPE, and they are ending up into the riverine belt, and they are because of the masks, the other PPE kit, like including the gloves, etc. We are seeing on the sites, and the beaches, the South Asian beaches would have more of this quantity of this materials. You see, this is during the pandemic time. The open burning is occurring in different parts of the country. And this was in Gujarat during the pandemic when we were trying to see the contamination levels in the water. But we see that a lot of cocktail of contaminants can come in, and these contaminants actually can come in the form of plastic additives and in different waste stream. So the waste stream, the municipal or the domestic waste stream, or these practices that we have, it is more influencing even when in the lockdown phase, when everything is closed. We may not see much water quality, deterioration in terms of industries, but our handling of waste is one big concern. And get exposed to this plastic additives through varied pathways. If it's there in surface water, like something like in River Ganga, that can come to groundwater, and the water that is also used for agricultural purpose there, the surface water itself, that could also lead to exposure through varied pathway. So to understand this more, we have our own medical school. So we are trying to understand how it can be transported from the mother's milk, the lipophilic compound, to the next generation. And as somebody introduced, we have a patent on a pencil, like we are trying to recycle the plastic to replace wood with the polymeric materials. But again, we are giving a coating so that other fragments of plastics don't end up, and which can cause problems with the plastics. And as part of ACU, like visitors coming over here, and we have jointly come up with some of the polymer blocks where we are using as a filler material for this plastic waste. And not only that, we using biochar augmented constructed wetlands, which I have named it as Mantrapod for us. We are trying to see how this constructed wetland can help to recycle, the wastewater that is coming, and can take care of. We worked extensively on bisphenol A, especially the typical biochar that we have is able to remove as a good adsorbent for this molecule. And we do a lot of outreach programs every day. On 2nd October, entire group, a lot of students join us. And yes, again, plastic is a problem. You can visualize it here. We try to make the community understand that how the problem can enter in the long term in their lives, how it can be really a problem. So we try to do a lot of outreach programs as well. So with this, the last segment of this plastic work, that ongoing work is going on. I have to acknowledge Inaugural project, where we are trying to understand this plastic and chemical pollution in varied Indian rivers. And of course, last but not the least, my entire group, we are working together a lot, and I really enjoy being with them. Sometimes we are working day in, day out, but we are happily enjoying our research, trying to contribute as much as possible. With this, I thank you all for listening to my talk. And if there is questions to take up, I hope I didn't take extra time. And yeah, thank you.
Thank you, ma'am. Thank you so much for the elaborate presentation that you have given. I hope everyone got benefited with the presentation. We have few questions in the chat box, ma'am.
Before that, Vinith, 1 minute.
Please.
Thank you, ma'am. Thanks a lot. It's a wonderful presentation and it is very informative also. Thank you, ma'am. Vinith, you can proceed, please.
Yes, yes, thank you, sir. Sir, ma'am, Shakti Narendran has one question that what is your perspective in mitigating strategies of already existing different plastic material in riverine ecosystem and ocean?
Shakti Narendra, this is very important question. Whatever is already existing, that is something that we have to look at. Of course, the only way now we are seeing, actually we are part of a lot of this beach cleanup programs. So directly, one thing I understand, I'll tell you, any waste in our country or in developing economies, if you add value to that waste, nobody will throw it away. So one way is like if this plastic materials can be added some value, whether it is used as a film material, whichever material. So one strategy could be like, don't add more from now, like, or give it to us, we do something out of it. Otherwise, like whatever is existing, definitely there are a lot of outreach groups who are collecting. The existing ones needs a lot of cleaning process. Like how we rejuvenate the riverine system, we need to take care of this waste material. We need to get into the field and take care of the the beach cleaning process or river cleaning process. That has to come in action. Like we can frame in groups, go to all the rivers and do it. That's, I think, the one of the best way that we can have. And young generation like you can be the added help to us. We can do it all together. Yeah, we did that, after this flood in, this Kovalam beach near Chennai city. If you go, like a lot of groups of students, they were coming and trying to help this macroplastic littering. Because littering, once it is there as a litter, unless we take it out, we have no much choice. We cannot touch the system and do something there. So that's one big challenge actually. Yeah.
Thank you, ma'am. Dr. V. Sambath has one question. Ma'am, whether the river authority cleans the river water before entering into the next country?
That's a very big question. Actually, this is a transboundary river. So the river is supposed to not to be dirty, or we should not add excess load. River can take a load to a good extent, but excess load should not be there. But there are certain segments where they're keeping this STPs to take care of, the wastewater treated before channelizing to the river. I would say it like that. But with our markers, we are seeing many in the lower stretch of Ganges, many of these STPs are non-functional. So with those, I think like still they are working on it. This Namami Gange group and everyone, like they're trying to talk it out, how to handle that. But nature, I would mention this, nature has a very good way. Nature has this wetland belt, where even if it is entering to a neighboring country, the beautiful wetland, the Sundarban, the Sundari trees, the wetland ecosystem, that is able to cleanse a lot of good quantity of the waste that is coming in. Maybe we can replicate that as a constructed wetland and try not to channelize wastewater to the main water stream. So that could be a possibility.
Thank you, ma'am. Dr. Selvakumar, sir, you can unmute yourself and interact, sir.
As usual, excellent lecture and excellent work, in detailed work, in fact. So I have just a question on the transformation of the emerging contaminant, especially here in your presentation on the plastics. So how do you track the transformation happening from one place to the other place? For example, if you have a primary molecule that gets transformed into another secondary byproduct due to microbial impact or due to the environmental impact. So that is a major concern, because EC as such is an emerging contaminant and we don't know what is going to happen and how it is getting biotransformed. So how did you address this in your study?
Actually, I would tell you that we have not targeted the metabolites or the byproducts of this major molecules. We have gone only with the main product that is added as such to the plastic vessels or the plastic products. We have not gone to the byproducts, but yes, this definitely gives us a big arena that we should look into this aspect as well. Like a lot of microbial activity can produce a lot of byproducts as well. So in this core of study, we have not gone for the byproducts, but that could be something very, very interesting. And I think maybe we can think together to work out something. Because the microbial actions we have not done that, but I tell you, like, since we are talking about this, mostly for the plasticizers, it will take quite amount of time to get as a metabolites, like people do, you know, when it comes to human body in the urine samples, we see a lot of metabolites. We have not tracked the metabolites, so we may not see them. But then there is another factor, like say, for example, pesticides. In those cases, those are also now coming as emerging contaminants category. Some pesticides which are like say, for example, endosulfan. The endosulfan actually gets transformed into endosulfan sulfate, which is even more toxic. So those kind of metabolites are actually very challenging. And those, when they come into the system, when we have tracked, because this is what we have seen when looking into the pesticides part, that is actually very, very challenging. And to remove them, they're so persistent, it is not possible to remove them so easily, especially if they enter you know, the fresh water or even groundwater. It's very difficult to remove.
True. One more follow-up question. Is there a tracer, for example, if there is one particular plastic byproduct, and is there any tracer to identify that this may be the original product? So
you mean to say the original plastic?
Yeah. So is this some sort of a tracer which can be linked to the original product?
Yeah, that's what we are trying. What we are trying to do, say for example, when the original product, they are using certain mix in certain formulations, certain percentage ratio. So we are trying to see like whether the similar ratio is there in the water bodies also or not. Say for example, you know, most of the plastic products, they will use huge quanta of DHP. So when we are seeing DHP, we know, okay, this is from the products directly. But some example, say for example, diethyl phthalate, which we're seeing more in the upper stretch, that we are seeing, when we saw that, we were surprised, like, how do this comes? This is not used much in the product. Then we started this model experiment with the bottles. And we see, like, this is because of the leaching from the recycled polymer. This doesn't come from the, so one is from the pristine molecule, DHP. Yeah. And DEP comes with a recycled polymer. When recycled polymer is used for some material that can give rise to, and that to what kind of material, like say this plastic bottles, mainly we could see that.
Okay. Sorry, Inba, please.
No, carry on, please.
Okay, the last and final question to Dr. Paro. We know that this concentration in a flowing river is a dynamic one, and I hope you have worked on a graph sampling process, right? Is it a graph sampling or a continuous?
It's a graph sampling. It's a composite sample. Yeah, it's a composite sample.
So, did you do any time variation studies, or because being Ganges, you know that its flow variation is very high during different time durations. You have a very high variation, and the variation itself is a big study. I know that the study what you did is a very extensive study, and it will be very challenging to study throughout the year. So, how did you handle that? The variations.
That's very important and a very interesting question. See, the one that we did was a screening study along the entire band. We chose the time in the month of March, where the monsoonal impact is not at all there. But then what we did, when we took a small case study for the lower stage of the Ganges, we tried to understand the seasonal pattern, the monsoonal impact, like pre-monsoonal, monsoonal, and post-monsoonal impact. Definitely during the monsoon, what we see, the more dilution. And the concentration levels in the same sites would go down. But the pre-monsoonal level, like what we are talking about in the month of March, this is the time where usually it is the entire for 2-3 months, the river is pretty much systematic, like nothing much happens in terms of other than the flow rate. And what we have done to understand like that point of time, we couldn't trace with the flow rate. We took out the published flow rate and tried to understand the fluxes that may enter as the river is flowing down. But what we saw was like sometimes, the monsoonal phase, we may not see these compounds much in the water, but the other source that can come in during the monsoon, what we saw was certain areas where there were this stormwater outlet. Those areas runoff was very high. So we could see some spikes, certain spikes in certain segments of this kind, where the surface runoff or the stormwater discharge is high from the households. Those cases, we saw certain smaller spikes. But monsoon do influence. We are looking into that also. It's a quite lengthy process. So we have taken the small, nearly 50-kilometer stretch in the lower stretch of Ganges up to the Bay of Bengal, and including the fresh water and the mixing and the marine zone. Yeah. So that's the case study. Basically, the one scholar has taken as a PhD topic. Yeah.
Oh, great. Nice to hear your lecture again. Thank you.
Thank you.
Over to you. Over to you, Inba.
Actually, this question is for both the Selva as well as to Dr. Paromita. Actually, from the lecture, the talk, it is well known that there are plasticizers or mixing in the drinking water. As the one slide which shows the bottle is depends upon the fresh bottle and recycled bottle, the plasticizer are getting mixed. Is it there is any device to filter those plasticizer, or it is any absorbent is available, or it is possible to detect? Because after hearing this, I'm a little bit afraid of drinking water from the can. That's what.
I would suggest don't go for a drinking water. I can't name the brands, but I can just say like one who is locally available and this less price for the same volume. Better to carry a water bottle with us. Yeah, actually.
But of course, Of course, this forum is creating some awareness, but generally people used to travel to some rural, other than that, if I'm going to my village area, there will be some bottles whichever available that I am forced to buy that and I have to drink that. Maybe it is very cheaper in cost. That's what I want to mention here. Yes,
yeah,
please.
The cheaper cost comes with the recycled polymer. Yeah. So if they are using recycled material, the cost will go down. And another thing is, if those bottles are kept outside, any water bottle, the plastic bottles kept outside for a long time, we should not be using. Actually, the idea came to do this model study was we were sampling in the Pudupet area, and usually we are very thirsty. Suddenly I saw like a lot of bottles were hanging outside in the shop, and it clicked me like how long this bottle are being, they are there because it's a hot summer day. And then I started asking question to the shopkeeper, and he said 2 to 3 days they will keep the bottles. Then it clicked like, okay, why not we try this? And unbelievable, like the Aquafina or Bisleri, they are branded ones, but possibly they are using the pristine plastic. So the release of the plasticizer would be lesser because they will have a coating. And unlike the recycled polymer, the same bottles when go for the recycling, and again because PET can be easily recycled. So PET bottles when goes for recycle, the recycled polymer, because again we are putting up in extrusion machinery, high temperature, again it's coming back, then the chances of leaching are higher. But then again, it was seen like if it was kept for a matter of like 2-3 days, the leaching was higher for only one brand. Again, I can't mention it, but that was like, above the permissible limit. So it's better to avoid, even when you are traveling in the train, etc. So I believe you got some hint, but yeah, that's there. That's what we saw.
But unfortunately, even if we are in Chennai, we always used to buy the 20-liter can, which is coming in the plastic cans only. So hope that is the same case in that. That's what I'm asking. Is there is any device to filter this or to observe this? That's what I raised this question.
What we are working on is like some kind of adsorbent. We are actually working on some nano composites. Two areas we are working. One is to try to understand kind of a nano sensor material. So we have started this work, but the adsorbent what we are trying is that we have augmented with the biochar with the constructed wetland. That we are seeing like, you know, those could be used for wastewater. But coming to drinking water, it's a big challenge. Drinking water, we honestly have not touched. It's a very tough area. And but maybe nano people like Selva might be able to answer that better. Like maybe you people can figure out a better nano filtering devices. But the chemicals, these chemicals are tough to remove. I think he would also agree to that.
Yeah, as rightly said, wastewater, okay, it has little bit lesser concern when compared to drinking water. So far, we don't have a proper certified material for the absorption of any plastic or byproducts of plastics. So it's a right way Dr. Paro is moving. We should find some alternatives. Unfortunately, I am also not working on that line. So I'm more into the metals and microbial systems. But we are also initiating the emerging contaminant line recently in collaboration with some international universities, where we are finding an alternatives for the entire plastic itself, not on the absorption side. Can we replace this plastic with something which is totally eco-friendly as well as safe for human use? So
Yeah,
that line, so that line we have taken instead of moving into absorption, because we felt that it's better to work on that line than removing the existing one, because this will take a lot of time, as well as we may not find the right solution for this.
Yeah, it is actually very challenging, and even we tried some small work with the bioplastics, like with the food waste or the waste material, converting those into plastic. But only challenge comes is like when with ACU students also, I see that even like that guy has published quite a good in Dalton, etc. But when coming to product to the industry, they are not able to take it up because of the cost effectiveness. Plastic is very cost effective.
One more problem is the VOC. So VOC is again a challenge, and we will be developing a material for one component, and another side will be getting evaporated. So we really will miss up, but it's really a challenging area. We have to think the contaminant from multiple points instead of one, not only on the surface charge or so we have to look into multiple. So it's really a big challenge. So that's how I skipped this removal section, and I ended up in a source replacement. So that we are working with University of Newcastle now. So no,
this is again, you know, like the wastewater we take up because already it is there in the system. We have to do something. And actually, you know, I didn't use any of those slides. What we are seeing during this pandemic time, when industries are shut down, okay, not only these chemicals, different chemicals that can come from household, especially this open burning. Every day I come from my office, my home to office. On the way, you will see, you might be encountering this open burning, all plastic material accumulated together and they are burnt. Maybe we need to at least stop this, like do some good awareness to start with, maybe with the common people. I mean,
Inba, I think we should give the opportunity to the participants, because we can talk anytime.
Sure.
Thank you.
Participants, if you have any queries related to the topic, you can have an interaction now, right now.
Ma'am,
yes, ma'am. The ma'am's lecture is very, very nice, ma'am. It's eye-opening talk. Whatever the active live research you are doing, that you are showcasing with us. Ma'am, any successful work using bacteria? Nowadays, research is on plastic digesting or plastic consuming bacteria. So if you are using that, what about the efficiency, the treatment efficiency? bioremedial options are there, using aquatic plant, using bacteria, treating contaminated water, having plastic contamination. This is viable. Any suggestions for this?
Ma'am, we have one segment where in remediation we were using not for plastic directly, but we were trying to remediate naphthalene in contaminated water and sediment. So what we did was we tried to get some indigenous microbes from the dump sites, open dump sites, that this burning is taking place. They are hot spots, and those microbes, we could isolate few novel strain. And one was so good that we were actually, when we were putting in the media, like within a span of 3 to 5 days, the complete removal of naphthalene without any byproduct. So this was one work done by one scholar, Dr. Sanchurajan, and he was working in ministry project on that. So this is what we were seeing, and currently we want to explore more onto it. So that was a very small segment which we saw, and we could even see that they can also be used as a how much impact is there, the contamination level. We exposed those microbes to different concentrations, and we just added one chemical to change the color, and we could see that they can also act as a risk assessment tool as well. But those that one species we have, that novel strain, that species could actually eat up all the naphthalene that we gave in the media. So that was the baseline we got, but I think we have to do a lot of extensive research. If we are happy with that, my wish, like the augmented nano material that we have, if we can compile this with these microbes and then have the constructed wetlands, it can be a holistic ecosystem.
Somewhat integrated.
Yes, that's one wish. So in segments we have done it now. Now we are trying to, we'll take some more time to compile it. Last 10 years we ended up here, so I don't know how long it takes. Yeah, but we are trying. Thank you for the question.
Thank you.
Vinit, you have to unmute.
Yeah, thank you, ma'am. Thank you for the wonderful discussion and wonderful presentation that you have given. Now it is.
Vinit, actually, yes. Ma'am, thanks a lot. And one more thing, I want to add one point, not a query or a question or anything. As Dr. Paromita, she said that the wetlands, which are naturally doing the process of neglecting this plastic from the waters. So being an IUCN SEM member, and as we have to take care of the nature-based solution, I want to pinpoint this here at this point. Thank you, ma'am. Thanks a lot.
Thank you. Thank you.
Thank you so much, ma'am.
Happy World Water Day to all.
Thank you, ma'am.
Thank you, ma'am. Now, this is the end of the first technical session we are having.